Do you know why Numpy is crucial for software engineer and developer roles? If you're working with data, Numpy is your one-stop Python library, which is widely used in data analysis, machine learning, and scientific computing. Even if you are not directly working with data, knowing Numpy can enhance your ability to handle large datasets, perform complex calculations, and optimize your code. Many tech companies like Google and Meta value this skill as it showcases your capability to work with real-world data and solve problems effectively. So having a gist of Numpy can give you an edge in interviews and make you more versatile developer. So what are you waiting for? Let's get started and make sure you are ready to excel in your next Numpy related interview. But before we begin, make sure to subscribe to Intellipaat YouTube channel and don't forget to turn on the notification bell so that you never miss out any updates from us.
So let's start our Numpy interview questions. Our first question is, what is Numpy and why do we use it? So basically Numpy is a Python library used for numerical computing, especially for handling arrays and matrices. And it's very popular because it allows you to perform complex mathematical operations on large data sets quickly and easily. And you know what, with Numpy, you can do everything from basic arithmetic to more advanced functions like linear algebra, Fourier transformations, and random number generation. And it is also very optimized for performance that makes it ideal for scientific computing and data analysis tasks. Whether you are working with data science, machine learning, or just need to solve numbers, NumPy can be a go-to tool for you that makes these tasks simpler and faster. So moving on to our next question. What are the advantages and disadvantages of NumPy? So let's start with it. Like NumPy is renowned for its efficient numerical operations, as I already told you, right? So obviously NumPy will be having advantages and disadvantages. So NumPy is renowned for efficient numerical operations, making it incredibly useful for handling large arrays and performing calculations quickly. While one of its disadvantages or limitations, you can say that it has a limited support for non-numeric data types, which means it's primarily focused on numbers rather than text or other data types. So the second advantage is that one of the best things that NumPy has is its simplified syntax for complex mathematical computations, as it allows users to perform intricate calculations with less code and more readability. While the disadvantage part is that working with every large arrays can be memory intensive, which means it can be a concern if you are dealing with limited system resources. So the third advantage is that a significant benefit for using NumPy is its seamless integration with other Python libraries like SciPy and Pandas. So why it is helpful? Because this integration enhances its functionality and makes it a powerful tool in the Python ecosystem for scientific computing and data analysis. But the disadvantage is that it's important to know that NumPy has a lack of built-in support for distributed computing, which means that it can be a limitation if you're working with extremely large data sets that require distributed processing. So another plus is NumPy's extensive documentation and community support. So there are numerous resources available, from official documentation to tutorials and forums, which can be extremely helpful. Despite these resources, NumPy also has disadvantages. Like the beginners might find NumPy challenging due to its steep learning curve, especially because of its complex syntax and advanced functionalities. So in summary, I will tell you that while NumPy offers efficient and powerful tools for numerical computations, it has also some limitations, can be daunting for newcomers. Anyways, its benefits and integration capabilities makes it a staple in the toolkit of many data scientists and engineers. So moving on to our next question, which is, what are ND arrays in NumPy? So basically ND arrays or n-dimensional arrays are the backbone of NumPy that are designed for efficient numerical computations and data manipulation. You can think of them as advanced tables or spreadsheets that can handle data in multiple dimensions. They are not like regular Python lists. ND arrays are optimized for performance as they allows you to perform complex calculations quickly. They support a wide range of mathematical operations that can store data in a structured format. So it doesn't matter if you're dealing with 1D array like a list or a stack, or 2D arrays like matrices, or even higher dimensions. ND arrays provides a powerful and flexible way to manage and process your data. So moving on to our next question. Explain the difference between shallow copy and the deep copy in NumPy. So the shallow copy creates a new object with references to the original data, while deep copy creates a completely new and independent object. So basically, shallow copy is a dummy of the original data, as you can say like that, while deep copy is a totally unique data which is not related to the original data. So the changes to the copied object affect the original because it is obviously the reference of the original. So whatever changes you will make in the copy, it will affect the original one. While in deep copy, changes to the copied objects don't affect the original. It's so simple to understand. Like, obviously, if a independent object is unique, so it will not affect the original data. It is no way related to each other. Shallow copy is very fast and it uses less memory, while on the other hand, deep copy is slower and uses more memory because it's obviously unique, so it will take time to generate. So basically, shallow copy is a type of process that copies only the top level structure, not the objects which are present inside or the bottom part. While deep copy is a unique copy or independent, so it has to copy both the top level structure and the nested objects all together. So moving on to our next question, which is, in a NumPy array, how can we access the elements? So in NumPy, accessing elements in an array can be done through indexing or slicing. If you want to access a single element, you can use the index like array index. For, as you can see from the screen, I have mentioned that how you can access a single element or slice of elements, or for multi-dimensional arrays you can use comma separated indices. So basically, for instance, array 2 retrieves the third element, and if you need a portion of the array you can use slicing. For example, array 1 is to 4 gets elements from the second to the fourth. In multi-dimensional arrays you can specify indices for each dimension separated by commas, as for instance array 2 comma 3 accesses the element in the third row and the fourth column, making it straightforward to work with complex data structures, right? So these are the way how you can access the elements. Moving on to our next question. What is a var function in NumPy? So in NumPy, the var function is used to calculate the variance of elements in an array, which helps them measure how spread out the data points are. You can compute the variance for the entire array or along a specific axis. For example, np.vr bracket opens array gives the overall variance, while np.vr array comma axis is equals to 0 computes variance along columns. The function is handy for understanding data variability and distribution. So as you can see from the screen, I have set an example here. So it is mice underscore array is equals to np, that is numpy dot array bracket. Again, we are mentioning the variables that need to be added in the array, that is 1, 2, 3. So basically, array is the function to create ND array, which will be telling that if it is a 1D array or a 2D array or a multi-dimensional array, while NP is obviously the NumPy object, and my underscore array is the variable that you will be using in the function, right? So in this, variance is a measure of the spread or dispersion of a set of data points, right? So moving on to our next question. How you can create arrays in NumPy that are 1 dimension, 2 dimension, and 3 dimension. So for 1 dimensional array, we can give this as an example, like we have to write import NumPy as NP. Then we have to put the variables as array, as here I have put 1, 2, 3, 4. Then we have to put NumPy underscore array to tell that we are mentioning that 1 dimensional array. And in the end, we have to declare that numpy.array and arr. For 2-dimensional arrays, the same process will be there, but for the variable part, we have to put one more array there. As you can see from the screen, I have put 4, 5, 6, 7, while the other process remains the same. For 3D array, here I am taking as a 3 variables, as you can see from the screen, 1, 2, 3, 4, then 4, 5, 6, 7, and then the last 7, 8, 9, 10, while the other process remains the same. So this is a very simple process, 1D array, 2D array, or 3D array. It's just you have to import numpy as np for all the cases, and the last two part, how to declare and how to print the array, is also same. It's just you have to change the number of variables according to the 1 dimension, 2 dimension, and 3 dimension. Moving on to our next question, which is, what are the or which common data types does NumPy support? So there are many type of common data types which is supported by NumPy. Here are the following that are used by the NumPy: integer types, data type types, object types, string types, boolean types, complex types, and the floating point types. So what is integer type? Basically, these are all the whole numbers like int 32 or int 64 used for counting or indexing, right? Then we have date time types. It is used to handle dates and times, enabling time series analysis. Then we have object types. It can store any Python object, making them versatile but less efficient. And then we have string types, which can store text data like my name, suppose, or anybody's name or any variable name, it is like that, and it is represented as fixed length strings. Then we have Boolean types, so it represents true or false type of case scenarios used for logical operations that have two options. Then we have complex types that handle complex numbers which have real and imaginary parts. Like obviously we have real numbers and imaginary numbers, so it handles that type of data type. And in the last we have floating point data types. Basically it represents real numbers with decimals like float 32 or float 64, essential for precision in scientific calculations. So these data types were that make NumPy versatile for different kinds of numerical and textual data processing. So moving on to our next question, which is how can the local maxima or peaks in one-dimensional array be found? So you can find the local maxima or peaks in a one-dimensional array using various methods. One common approach is to iterate over the array and to compare each element with its neighbor to determine whether it's peak. So for this we will see an example like how it works practically. So let's run the code here. So for that I will take any interpreter. So let's start with our coding part. For that we'll write import NumPy as np find underscore peaks, then I will put array and then semicolon. Then we have to write peaks is equals to, then put brackets, then we have to put for loop for I in range, and we have to mention what our range is. I will start from 1 comma, then we have to mention the length of array, and then we have to subtract it by -1. Okay, then we have to put semicolon. After this we have to write the if else, that the condition that if we have to see the length of the array is less than of its neighbors. So we have to compare two arrays. So for that the first array will take it as if array, then we'll put our value I is greater than array, and put again our value which is I minus 1. Okay, after this we'll put the second array which will be array I, and it should be greater than array I minus 1, right? We'll put semicolon and we'll append our indices which is peaks dot append, and we'll put our value which is I, and then we will return the peaks. So we have put our formula, or whatever you can say is a code formula. Then we have to take an example for this so that we will see how it works. I will write as examples uses. Then we will write array is equals to np dot array, or then we will put our array size or array variables which is 1, 3, 7, any random number, 2, 5, 8, 4. Okay, then we'll mention our peaks. We will be writing find underscore peaks, and then we'll mention our array. After that we have to print the array. For that we have to write print, open the bracket, peaks found at indices, and we'll put semicolon, inverted commas, we'll write comma, then we'll write peaks. Okay, after that we will write again the value of print. So to get the peak values, open the bracket, write peak values, and a semicolon, inverted commas, again then write comma, and we'll write an array, take a bracket, write peaks, and we are done. So let's run the code. So yeah, we got the output. The first one we got is peak found at indices which is 1, 2, 4, 5, and then the peak values are 3, 7, 5, 8. So this is how we can find the local maxima or peaks in one-dimensional array that needs to be found. So moving on to our next question, which is how is NumPy different from pandas? So basically NumPy and pandas both are powerful duo when it comes to data manipulation and analysis in Python. NumPy is really the backbone for numerical computing, as it provides efficient low-level data structures like arrays or matrices, and along with a vast collection of mathematical functions that can be used to operate on these structures at very high speed. And also this makes NumPy essential for working with large data sets and multi-dimensional data sets. So whether you are performing statistical analysis or training a machine learning model, you just need to fix some numbers and you can use NumPy. While on the other hand, pandas are built on the top of NumPy, that is to provide even more user-friendly and high-level data structures and tools. So the data frame basically in particular is a game changer that gives you a spreadsheet-like interface to work with tabular data. So pandas suite of data manipulation and analysis functions make it a go-to choice for tasks like data cleaning, merging, and aggregation, which are essential for preparing data for further exploration and modeling. Okay, So moving on to the next question, which is what is the difference between copy and view? So when you create a copy of NumPy array, it's like making a completely separate version of the data. The new array has its own memory location and can be modified independently of the original. And it is very useful when you need to work with version of the data that won't be affect the original. While on the other hand, view is a new array object that still references the same underlying data as the original. Any changes you make to the view will be reflected in the original array and vice versa. So views allows you to access and manipulate the data in different ways without having to create a separate copy, which can be more efficient. So understanding the copy versus view behavior is crucial when working with large data sets in NumPy, as it can have significant implications for performance and memory uses. So we will see this from a practical example. So let's see how to run this. So let's see how to put the copied array or what is a view array. So let's see with an example. So for copy array, we'll write import NumPy as np. Then we will write our original array. We will have to mention one of the original array which we want to show as an example. So we will put any number in that. It should not be any fixed number. It's up to you which one you want. So I will write as 1, 2, 3, 4, 5. After that, we have to write copied array, copied underscore array. Then we have to make it compared to original array. And here we have to write dot copy and we have to close the brackets. Okay. And in the last, we have to write which copied array or a copied array variable you want to put in the original array. So we'll write it as copied underscore array. We'll write bracket 0. Then put the values 100. So basically, I want my array to having 100 at the 0th or the first place. So let's see if it prints the value. For that, we have to write print original array, write semicolons, we'll close the inverted commas and comma, original underscore array. Okay. For the same, we will write as copied array, print as copied, wait a minute, yeah, copied array underscore, put comma, and write copied underscore array. So let's run the code. So yeah, see, we got it. The original array which we wrote as 1, 2, 3, 4, 5, the variables, and the copied array is having the value as 100. Okay. So what we got it from there, like if you will make changes in the original array or the copied array, it will again reflect it to the original array as well. So this is how copy array works. So now we will see view array. So now we will write the view array. So for that, we'll write import. So same, it should be like that. Import NumPy as np. We will write original array. We'll put np dot array. Again, some random number 1, 2, 3, 4, 5. We'll write view array. We have to mention which one we want to write. View array is equals to original underscore array, right? So we will write here as array dot view. Okay. Here we have to wait. Yeah. View, we write it, then we have to put the brackets. After that, we have to write which one we want to view in the original array, which will be view underscore array. So I will be taking the same number so that you get the exact reference how it works is equals to 100. Now we'll write print, same things, original array, underscore, comma, original underscore array. Okay. For this, we will write print, comma, view array, then same things, comma, view underscore array. So let's run the code and see what we get. So yeah, see, here there are two arrays which has been created and both the array has the same number. Okay. So copied array made a new array which was independent, and the view array made the two arrays, like first is original array and the second one is view array. And in the both the arrays, we have changed the value with 100. So this is how it works. Okay. So this is how both the arrays works. Okay. Now we'll move on to a next question, which is what is the difference between slicing and indexing in NumPy? So slicing returns a portion of the array as a new array. So basically in slicing, what happens if you mention array or if you declare a variable 1, 2, 3, 4, 5. So obviously slicing will be happening in such a way that from those values only the return is possible. While in indexing, it returns a single element or a subset of elements from the original array. So basically, it will not cut the portion, it will only put one of the single elements or a subset of elements from the original array. This is how indexing works. While slicing allows selecting a range of elements using start, stop, and step parameters. As already I told that it collects a portion, so you can select a range of elements. While in indexing, you have to select a specific element or elements using integer indices. So we can only do a specific element or elements that are having integer indices in indexing. While in slicing, we can create arrays with fewer dimensions than the original array. On the other hand, indexing can access individual elements or subsets of elements from the original array, right? So we can access both the things. As you can see from the screen, slicing has a syntax as array, bracket start, semicolon stop, semicolon step. While on the other hand, for indexing, it is array index or array row index or column index. So obviously, if you are putting an individual or single elements to, you have to mention like this. Okay. So moving on to our next question, which is, what is vectorization in NumPy? So basically, vectorization in NumPy refers to the ability to apply operations to entire arrays at once rather than using loops to process individual elements. This is made possible through NumPy support for element-wise operations, broadcasting, and efficient array manipulation techniques. Vectorization leads to more concise, readable code and can significantly improve performance by leveraging optimized low-level implementations. So when you perform operations on NumPy arrays, the operations are automatically applied element-wise, meaning the operation is executed on each element of the array simultaneously. So this can significantly improve computational efficiency compared to using explicit loops to iterate over each element. So basically, what we can see here is vectorization is basically, it is the process that can be applied to the whole of the arrays. So you don't have to put individual elements as that. Okay. So as you can see from the screen, I have mentioned the picture as like for the X, we have cut the whole part at 1, 2, 3, 4. While in the Y thing, we have cut the whole as 5, 6, 7. So we didn't have to put one single element as 1 or 2 or 3 or 4. And same for Y, like 5 or 6 or 7. So we put the whole value as 5, 6, 7 and 1, 2, 3, 4. Okay. So this is how vectorization works. Moving on to our next question, which is, what is array slicing and how do you do it in NumPy? So for example, take an array as 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 in the screen and consider different cases as shown in the image along with the respective outputs. So for that, slicing is the process of taking a subset of the provided array and using it to create a new view of it without actually copying it. In NumPy, array slicing is performed using the colon operator within square brackets. And the syntax is, as I told, start, stop, step. So where the start is the starting index, which is inclusive, stop is the stopping index, which is exclusive, and step is the step size indicating the spacing between the elements. So as you can see from the screen, the first one is bracket 2 is to 5. That is 3, 4, 5. So how it got? So on the second space of the element, which is 3, you have to make it end at index 5. So what we can do is, so suppose it starts from 3. So the given index will be 3, 4, 5 because at the second element we have 3 and the last index we need to have is 5. So all the elements between 3 to 5 should be written as here. So we wrote as 3, 4, 5 and then we have semicolon 6. So what is semicolon 6? So we should start from the beginning and it should end at index 6. So obviously we should start from the 0th value. So which is 1, 2, 3, 4, 5 and we have to end at 6. So it is exclusive, so we don't have to put the 6th value. So we'll write it as 1, 4, 5. Okay. So now after that we have 3 plus 2, which will be, so we'll have to start from the 3 value and then we have to go to the end. And then we have semicolon, semicolon, minus 1. So basically we have to reverse the array for that. So how are we going to do it? So we should start with the last nth element, which is 10, and then we have to go till 1. So we'll write as 10, 9, 8, 7, 6, 5, 4, 3, 2. So this is how this array works. And then we have 1 column 7 column 2. So it means you should start the value from index 1 and at index 7, while the step will be, you have to divide it by 2. So first one is 2. So we write it as 2. Then we have 7th element, which is 8. So we divided it by 2. So it is 4. And then we have 10th element as 10. So divided it as 2. So it will be 12. Right. So it is 2, 4, 6. And then in the last we have 8 is 8, column 3, column -1. So we have to start at index 8 and then end at index 3 and step by -1. So it will be 98765. So this is how array slicing works. Now what is masked array in a NumPy? So basically in NumPy, an array that has additional boolean mask added it to the designated sum entries as invalid or marks is called masked array. As a result, you can deal with data that contains incorrect or missing numbers without having to change the original data. So basically what is a masked array is that suppose I have an array as 1, 2, 3, 4, 5 and then there are multiple values, but there are few of the invalid values which are not used here. Okay. So what this array does is that it will mask or it will cover those values so that you get to know that these are the invalid values. So you don't have to make the changes, as you can directly see which are the wrong values and which are the right values. So this is how masked array works, and so this is what masked array means also, right? So moving on to our next question, which is how is flipper different from flipped methods in NumPy? So an array can be flipped left or right using the flip lr function. Although the columns remains unchanged, the pieces within them are arranged differently than they were previously. So the following graph serves as an illustration of this. So first, as you can see, 1, 0, 0, 2, the first column is that, and then we have 0, 1, 2, 0. So after putting the flip lr method, as we can see from the screen, and the syntax is np.flip lr bracket arr. So whether the array that has to be flipped is donated by arr. Okay. So here the left side elements got changed to the right side and the elements got shifted to the left side. Okay, left or right according to the need. So it was present first as 1002, then it got changed to 01 and 20. Okay, so this is how it works. So moving on to our next question, which is how do we extract the diagonal elements of a square 2D NumPy array matrix? We will write as import NumPy as NP. So we will now create a square 2D NumPy array, or you can say as matrix. So we'll write matrix is equals to NP dot array, and then we'll put our values 1, 2, 3. Then the second one, which is 4, 5, 6, and the last one is as comma bracket 7, 8, 9. Okay, so these are my values, and they will write as diagonal underscore elements is equals to np dot diagonal matrix, right? After that, we'll print the diagonal elements which we want, diagonal elements. Okay, so now let's run the code and see if the elements are printed or not. Wait a minute, it got some error. Okay, I put the full stop here. Now run the code. So yeah, we got the output. See, as you can see from the screen, I have changed the indentation as I wrote it in one sentence. Now I change this to the third sentence. So as you can see from the screen, we got the output as 159. So this is how we can find the 2D NumPy array, and we can find the diagonal elements as you can see from the screen. So moving on to our next question. Create a program that adds spaces to each character in every NumPy array entry. So basically, for that to add spaces to each character in the strings of NumPy array, you can follow the following steps. For that, we have to write the code. So again, we'll go to our code. Yeah, so we'll write as import NumPy as np, and we'll define add spaces to array. Okay, and put arr. So basically, we converted the array to a string type, and now we have to add spaces to each character. Array is equals to arr dot ace type. So we'll write as a string, which is str. So basically, now we'll put spaced array, which we want to see as spaced array is equals to np dot char dot add. We'll write arr, comma, then put brackets to put the spaces. Okay. Now we'll return spaced array. Got it? So this is our code. Now we'll put our example, like which thing we want to space it. So for that, we'll write array is equals to np dot array bracket. We'll write. So yeah, we will write our array values. So I will write it as Intellipaat. Then I will put other word with as software. So we'll write anything. We can write anything here. I'm writing so that you get to understand how it works. Solutions. Okay. After this, we'll write spaced array, which one we want to space it. paste underscore array. Then we'll write is equals to add comma spaces, sorry, underscore spaces to underscore array. Right? And we'll put the array again. After this, we'll write it as print space array. So let's run the code. So yeah, see, we got the output as Intellipaat software solutions, and we got the space in between as well. Okay, so this is how add spacing works in NumPy. So yeah, let's see our next question, which is find the eigenvalues and eigenvectors of matrix using NumPy. So for these, to find the eigenvalues and eigenvectors of a matrix using NumPy, you can need to be following these steps. First, you need to import NumPy. Then we will create the matrix. Then we will compute the eigenvalues, and then we will compute the eigenvectors, and at the end we will print the results. So how we will write the code for this? We will write it as import numpy as np. Then we will define a matrix for which you want to find the eigenvalues and eigenvectors. So I will write as A is equals to np dot array, the brackets, and one more bracket. So we'll write 4 comma minus 2, and then we will put our next value, which is 1 comma 1, right? So these are matrices values. Then we'll write eigen values comma eigen vectors is equals to np dot linalg dot eig, and then our number, which is a. Okay, so why we wrote this? Because to compute eigenvalues and eigenvectors, you have to use np.linalg.eig to compute the eigenvalues and eigenvectors of the matrix. This function basically returns a tuple containing the eigenvalues and the eigenvectors which are corresponding to each other. So now we'll print eigenvalues semicolon colon eigenvalues, and we'll put for the same as eigenvectors. So basically we are just changing it to caps eigenvectors, and obviously we want these two in different line, so we'll write it as like this, and we'll close the bracket comma eigenvectors. So yeah, let's run the code. So yeah, see, we got the eigenvalues as 3 comma 3 dot 2 dot, right? And the eigenvectors are 0.89442719 and 0.7010678. So these are the eigenvectors divided, basically it got divided into two parts. So this is how eigenvalue and eigenvector works for the NumPy. So yeah, moving on to our last question, which is write a program to reshape a 1D array, NumPy array, into 2D NumPy array with a given number of rows. Okay, so to reshape a 1D NumPy array into a 2D array with a given number, you have to follow certain type of steps, which are import NumPy, create your 1D array, determine the number of rows, and calculate the number of columns. Then we have to reshape the array, and then in the end we have to print the reshaped array. Okay, so let's start our code. So let's start with our code. So we'll write import numpy as np. We'll write original array as original is equals to np dot array, and then we'll put our values, which is 2 5 2 5 7 0. So you can put any value. I'm putting random numbers. So now we have to mention the values of rows we want to put. Rows equals to, so I want 3. Okay, and after that we have to write reshaped for array is equals to, and then we'll write original underscore array dot reshape number of rows comma minus 1. Okay, so this all should be in one line. Okay, got it. After that we will write print original one dimensional array, it's semicolon. Now we'll write print original. So after this we will write print, then slash n to put it in the next line, reshaped 2-dimensional. Okay, yeah, understood. After this we'll write print reshape. Let's go. Now run the code. So yeah, we got the output. See, original one-dimensional array was 25714, and after that this code reshaped it as 25, then 70 and 14. So this is how you reshape the code. So with this, we have come to the end of this video. And if you found it helpful, then do share it with your fellow mates. And also don't forget to subscribe to our Intellipaat YouTube channel for regular updates like these.
Just a quick info guys, Intellipaat offers a data science course which will help you master Python, SQL, machine learning, AI and Power BI. Get a data science certification from IIT Pavatak and Innovation Hub of IIT Madras. With this course, we have already helped thousands of professionals in successful career transition. You can check out their testimonials on our Achievers channel, whose link is given in the description below. Without a doubt, this course can set your careers to new height. So visit the course page link given in the description and take the first step towards the career growth with the data science course.